Hi everyone, this is me Bilal Malik. In this video lecture, I am going to present you how to design a digital DC voltmeter using a PIC microcontroller. So in this lecture, we will talk about digital DC voltmeter. In this lecture, I am not going to talk about AC voltmeter. I will talk about it in my upcoming videos. So as you know, by voltmeter means you want to measure a voltage of your source or anything or any circuit. So in this lecture I am going to teach you how you can design a digital DC voltmeter using microcontroller. In this video I am using pic1f877a microcontroller, and as you know, microcontroller have pic1f877a microcontroller have built-in ADC. ADC means analog to digital converter. So this analog to digital converter is used to measure DC voltage. But as you know, microcontroller cannot measure voltage more than 5 volt, because microcontroller's operating voltage is between 3.3 to 5 volt. Voltage greater than 5 volt may damage microcontroller permanently. So we need to find a way in which we can step down a DC voltage to the input of ADC, and we can provide microcontroller from damaging. So for example, this is our microcontroller, and we want to measure DC voltage, and this is connected with ADC, and we want to display this voltage on LCD. So for example, if we want to measure 40 volt DC, so we cannot connect a 40 volt DC directly with the microcontroller, so we have to build some kind of circuit in between a microcontroller and AC DC volt source. So what kind of circuit we can use? So there are two circuits which typically use for for step down purpose. Number one is voltage divider. I think you all of you are already familiar with the voltage divider. Another circuit is difference amplifier. You people have heard about amplifier already, but you may not be familiar with difference amplifier. So in this video I am going to explain both these methods, but for practical demonstration I will be using only voltage divider method. So let's discuss both methods one by one. So first we will discuss a voltage divider method. So in case of voltage divider, as you know, we use two resistors, and for example we have these two resistors, and we have connected a 40 volt DC here, and we want to step down it into for example 4 volt. So 4 volt is less than 5 volt, and the microcontroller can measure this voltage easily, and here it is connected with the ground. So we have to determine the values of R1 and R2 to convert 40 volt into 4 volt. As you know, the formula of voltage divider is V0. For example, this is V0 and this is V input or V in. So V0 is equal to V in multiplied by R2 divided by R1 plus R2. So why we are using R2 here? Because we are measuring voltage across this resistor. If we are measuring voltage across this resistor, we should have this formula would be V0 is equal to V in multiplied by R1 divided by R1 plus R2. But we want to measure voltage across this resistor, so we are using R2 over R1 plus R2. So let's put the values of V in and V naught in this formula. So V naught is equal to 4 volt, and V in is equal to 40 volt multiplied by R2 divided by R1 plus R2. So by solving this equation, it will become 4 R1 plus 4 R2 is equal to 40 R2. So 4 R1 is equal to 36 R2, or R1 is equal to 9 R2. So it's mean our value of R1 should be 9 times value of R2. If we want to convert 40 volt DC into 4 volt DC, we should choose values of R1 and R2 in such a way that value of R1 should be 9 times of value of R2. So for example, if we choose R1 as a 1K, we have to choose R2 as a 1K, we have to choose R1 as a 9K. So in this case, value of R1 will be 9K and value of R2 will be 1K, and we have connected 4 volt 40 volt here, and output will be 4 volt. So this we can measure this 4 volt with the help of microcontroller, or we can connect this to the input of ADC of our microcontroller. So this is the simplest method which is used in many electronic circuits to measure high voltages. But in case of more high voltages, for example voltages more than 50 volts, many people don't recommend to use voltage divider circuit. In this case, we use voltage difference amplifier circuit. So let's discuss voltage difference amplifier circuit. So in case of difference amplifier, as you know, people are familiar with the amplifier. So it is just a modification of amplifier. As you know, amplifier, this is the symbol of amplifier. This is inverting and this is non-inverting input. We connect a resistor. Here is feedback, and we connect our DC source here, and 40 volt, and we calculate values of R2, R1, R2 and RF in such a way that basically values of R1 and R2 select the gain of amplifier. We select values of R1 and R2 in such a way that it gains this is the value of 40 volt, and we will get an output of 4 volt here. And I recommend you to read about difference amplifier from any electronics book, because it is not it is beyond the scope of this video to discuss difference amplifier. I just giving you a review of how difference amplifier is used in to step down DC voltage, and this input is given to microcontroller ADC. So basically the formula of V naught of difference amplifier is gain R2 by RF by R1. So this formula is used to calculate gain. You can adjust values of adjust the values of R1 and RF to calculate your gain, or calculate your gain and calculate values of output voltage. So these are two methods used to determine used in digital voltmeters to step down voltages. So let's discuss the main circuit diagram. For example, in this circuit, sorry, this is a circuit diagram for digital ammeter. Let me bring circuit of digital voltmeter. Here is a circuit of digital, here it is. So as you can see, in this is the circuit of digital voltmeter using PIC microcontroller. This is the basic circuitry for digital DC voltmeter. We are using pic1f877a microcontroller. This is the oscillator circuit, and here we are using 40 volt battery, and we want to measure voltages of this 40 volt battery, and we are using R1 is equal to 18k and R2 is equal to 2k. So it will basically convert voltage 40 volt into less than 5 volt. For example, by using voltage divider formula, we can verify it. Vin is equal to 40, R2 is equal to 2, and divided by 20, and it will become 4 volt. So microcontroller ADC can easily measure 4 volt. So here we are connected this output to RA0 pin of PIC1f877 microcontroller. RA0 means channel number 1 ADC of PIC1f877 microcontroller. PIC1f877 microcontroller have 6 ADC channels. This means we can connect 6 physical or analog devices with this microcontroller, and here we are using LCD to display this voltage, and LCD is connected with port B of microcontroller. So this is the basic this is the circuit diagram of digital DC voltmeter using a voltage divider method. If we want to use difference amplifier, you just have to replace this circuit with difference amplifier, and the advantage of this difference amplifier is that you can measure voltages more than 50 volt with the help of difference amplifier. We can still measure voltages with voltage divider more than 50 volt, but it is common practice to use difference amplifier in case of voltages more than 50 volt. So let's discuss the code. For example, this is the code of digital DC voltmeter. So first of all, these are the lines which used to define LCD. Let me tell you first, this code is written using micro C for PIC. You can download it from microelectronica website. So these lines defines we have connected LCD pin RS with microcontroller RB4 pin. RB4 mean port B pin number 4, and similarly we have connected LCD enable pin. So this tells the compiler we have connected hardware pins in this fashion. RS pin of LCD connected with RB4, LCD pin of enable connected with RB5, and so on and so forth. These lines define the direction of port, and after that we have defined integer variable AD read, and after that we have defined voltage, float voltage, and here we define a character, and this is the main function. In this function we are defining port A is equal to 0 by writing port A is equal to 0. We defining port A as a input, because ADC uses input, and TRIS defines that it is used as input, and port B is equal to 0 defines it as output, and test B is equal to 0 it also defines it as output. So these are the functions. These are built-in libraries of micro C which defines LCD, which initializes LCD ADC, and here we are writing LCD command which will turn off the cursor, and this is command to use to clear LCD, and here we are displaying LCD out digital voltmeter. It will display digital voltmeter on LCD whenever it is turned on first time, and then there is a delay of 1 second, and after that this is the main function which will going to execute every time. So first of all, here we are using voltage variable to store value of ADC, and here we are converting voltage over ADC value into voltage. So if you don't know how to use ADC, I recommend you to visit my website microcontrollers lab.com. You can also find the link of my website in the description of this video. Basically ADC works on the principle of counter. We are using 10-bit ADC, so 10-bit ADC can measure lowest possible voltage is 4.8 volt. After reading every 4.8 millivolt microcontroller counter counts from 0 to 1023. So after reading every 4.8 millivolt, it start incrementing. If it reads double than this value 4.8 volt, microcontroller will read 2. If it reads 3 times this value, microcontroller will read 3. If it reads 4 times this value, microcontroller will read 4. So for example, microcontroller reads 573, so we can convert this value back into voltage by multiplying it to 5 and divided by 4023. Basically 5 by 1023 is called resolution of ADC. I recommend you to read more about how to use an analytic converter on my website. After that, we are using here you can see I am using 5 by 1023, sorry, it is 1023, and also multiplying with 10. What is this? Why we are also multiplying with 10? Because we are using a voltage divider and this value is 18k, this value is 2k. So and we have this is 4 volt. So basically in this case we are using voltage divider value, opposite value of voltage divider. For example, if you recall the formula voltage divider was V naught is equal to V in multiplied by R2 divided by R1 plus R2. So here we are using it in opposite direction. For example, we want to measure Vn. So what we are doing, Vn is equal to V naught multiplied by R1 plus R2 divided by R2. Okay, so V naught, we have calculated V naught using voltage multiplied by 5 divided by 1023, and we are multiplying it with V naught, and this is V naught is equal to voltage multiplied by 5 by 1023, and this is the value we've calculated using this formula. This formula is R2 plus R1 divided by R2 for this formula. That's why I'm multiplying with the 10, and this function is used to convert integer into string because we want to display it on LCD, and these are the simple commands. Okay, so this is the basic overview of how to design a digital DC voltmeter using pic1f877a microcontroller. So if you have any questions, and if you want to read more about digital DC voltmeter, I recommend you visit my website. You can find a link of complete article and code on my website, and link is given in the description of this video. Thanks for watching this video, and keep sharing this information with others.